Okay, this is an example problem associated with chapter 27, which is a shift register chapter. So this is by nature a shift register problem. So this is a interesting problem that has a couple of features in it that you should be aware of. Okay, so essentially what I want to do is take an input and multiply it by 5.5, which is essentially 5.5, of course. And so the issue here is I don't really know how to do multiplication other than multiplying by 2 or dividing by 2. And so the issue here is I'm going to use a shift register to multiply by 2 and divide by 2. So for the first thing I got to figure out here is how I am going to synthesize a 5.5 using a shift register. So there's a whole bunch of ways to do this. I could actually divide by 2, which gives me a half, and and add that 11 times, which is 5.5. I could do a whole bunch of different things. I could just add it to itself 5 times, then add a half to it after I shift it right. But I'm not going to do that. I'm actually going to add 3 different values here. And then the 3 values I'm going to add are 4. Maybe I'll write that in here somewhere. 4 plus 1 plus 1/2. So I need to synthesize those values somehow. And what I'm going to do to get the 4 is to shift it left twice. What I'm going to do to get the 1 is just load it. And what I'm going to do to get the half is shift it right 1 time. Okay, so what else is interesting in this problem is the 8-bit inputs here. I need to make sure the answer is going to be valid, which means I need to fit an 8-bit unsigned number times 5.5. I need enough bits in the output to represent that number. So what I need here is a couple extra bits. The question is, how many extra bits do I need? So if I just was multiplying by 2, I could get away with 9 bits. If I was multiplying it by 4, I could get away with 10 bits. 10 bits, multiplied by 4 is still not enough to accommodate 5.5, but if I added 11 bits, I could get up to a multiplication by 3. So adding 3 extra bits on this thing is what I'm looking for. Okay, so the output is this thing on this circuit is going to be 11 bits. And I'll put the value in there also. And it's going to be a clock circuit. And it's going to have an input value. We'll just call it data of 8 bits. And what else do I need in it? I think it has a button in here. Pressing of a button. So BTN, we'll toss a button in there. And I think that's about it. And so what else here? So this would be a pretty easy problem to do without a shift register, but because I said you can only use one ripple carry adder in this design, you pretty much need a shift register. Okay, so I think that's it on this thing. Oh, the last bullet is the input is going to stay around a while, which means I can keep reusing that, and essentially what you'll see is I'm going to continue loading this into a shift register, then monkey with it. Okay, so looking at this problem, the first thing you can see in this thing is I'm adding up these 4 different values, which is an accumulation function. Okay, so this problem necessarily has an accumulator, so I'm going to put that in there without thinking too much about it. And there's my value on the output. Since it is an accumulator, and I always want to pretty much start these accumulators at 0, so I'm going to give myself the ability to clear it. I know I need some load control on this thing, and I need my RCA. There's my RCA. The output of the RCA is going to go into this register, and one of the inputs to this, oops, I guess you can't go off the screen on this thing. Okay, one of the inputs to this RCA is going to be the output of the register. The question is, what is the other input going to be on this? And I'm going to keep everything in here 11 bits. and that's going to be good and happy. Okay, so what else do I need on this thing? I need another value in this thing. So this problem necessarily has a shift register, so I'm just going to draw shift register. I'm going to call that my universal shift register. It's going to put the data input into this thing, and I'm going to call this coming in at 8 bits, but I'm going to add some extra bits to it, stuff some bits in there before it gets in there. It is a clock circuit. And what else do I need? I have it's my universal shift register, so I need to select the operations. And the one I'm going to do this is 00011011. This is SEL. This is the operation. Hold, load, shift, left, shift, right. Okay, so that's everything I need to do for this problem here. The only thing here is the other operand for this RCA is going to be the output of this the shift register. So essentially, I'm going to be accumulating values from this shift register. So this is 11-bit input. And do I need anything else? This probably has a D bit in it, but I think I can ground. If not, I can go back and repair that later. Well, I think I'm ready to do this problem. If I forget something, I can just go back and add it later. So this is A, B, and I've got a sum. I could throw that in there. Okay, so the first thing in the first part of the state machine is I am looking for a button press. BTN. And so long as the button's not pressed, I transition back to that state, but I have some other issues here, such as I'm sorry, I need to draw a state machine on this thing. Okay, so the control on this thing is going to be these control inputs to the register, which is a clear, which is also a load, and also have over here I have the select inputs, which I need to control also. Here's my select inputs, and I need some FSM. I need some status input, which is essentially going to be the button. And I think that's it on this thing. Okay, so here's the button. Remember, for each of these states here, I'm worried about what these control outputs are doing. And okay, so if I don't get a button, I need to make sure I don't clear this thing, and make sure I don't load this final output register there, and that looks good. But once I get a button press, I need to do something. And so I'm gonna be clever about this. I'm gonna make this a Mealy machine. Once I get a button press, I'm not gonna clear it. Oh, I am going to clear it. That's right. I am going to clear that output register. I'll say I'm not going to load it. Probably don't need to do that. But most importantly, I need to get that data into the shift register. So I'm going to come over here and load that shift register. And just for clarity, it doesn't really matter here. I think I'll put in a select of 00 for that state. Okay, so when I get into this one state, load this R1, once I get into this state, I will have that value loaded into the shift register, and also this output will be cleared. Okay, from this state, what I need to do is turn that load signal on, and then transition to the next state. So with that load signals on, it's going to take the output of this shift register and add it to the output of this register, what I cleared here. And so what this is going to do is, at this stage here, the shift register has been loaded with that data value. So that's my 1. That's this 1 right here. I'm officially adding that to the register. Okay, so that's going to work. And I guess at the same time, I'm going to make sure I don't clear that register, but I'm going to do, just for the heck of it, I guess I'm going to do a shift. Let's go ahead and shift right. Okay, so shift right. At the same time, I'm loading the current value of the shift register into the output register into the accumulator there. I'm actually going to shift it right. So when I shift it right, that's going to give me the half value, and looking good there. Okay, so this is a don't care here. So in this state, I've loaded the accumulator with the data value. I've also shifted it right. So when I get to this state, I'm going to say LD accum. I don't know if that's a good name or not. 1/2. That's probably a horrible name, but good enough. Okay, in this state, I'm going to load the shift register. I'm going to load the output accumulator once again. I'm going to turn the load on. I'm going to make sure the clear is turned off, and then when I exit the state, it's going to add 1/2 to the 1/2 to the value that's currently in the accumulator. So the key here is I am going to, at this point, load a new value into the shift register. Okay, so the issue here is I've got a 1 after I leave this state. I've got a 1 plus 1/2 into that shift register. What I need to do is add a 4 to that, and the way I'm going to do it is load a new value into the shift register, and I'm going to turn the select to shifting a left, right? Because I need to multiply by 2. I'm going to make sure I don't load this thing, and I'm going to turn the clear off. Okay, so after I exit this state, I'll just call it X2. I will go to a new state, which when I exit this state, I will have, by the time I enter this new state, I will have 2 times data in the shift register. So I need to shift it again. 1, 0. I'm still not ready to load it. I certainly don't want to lose what I have in that thing. I'll call this X4. And I'm going to come to the new state here, where I turn the load on, leave the clear off, and at this point, selects a don't care. And this is the load 4 state. Okay, so this state here got multiplied it by another 2, which means that in this LD_4 state, I have the value of 4 times the input data in the shift register, and I'm ready to add it, which I do by turning that load on, and I'm making sure it's not clear, of course, and I think that's it. And then I can go back to the beginning and wait for a button press. And so once again, summarizing here, the first thing I did in this thing was I loaded the shift register, and after I loaded the shift register, I cleared the accumulator at the same time. I loaded that first value of data into that accumulator. Before I left the state, I right shifted it, which gave me a 1/2 in this new state here, and that's another value I want to accumulate. So I loaded it again. This is also a clear knot. And okay, so I've got a 1/2 in the shift register. What I need there is to get a value of 4 times data in there. So what I do is I reload a new value, and right here the select is loading new value. By the time I get here, I have a data in here. I multiply, when I leave this state, I multiply it by 2 by shifting it left, which gives me twice the data in this state. In this state, I'm going to multiply it by 2 again. There's your multiply by 2 with the SLL equals 1, 0. By the time I get in this state, I have 4 times data in the shift register, which is the value you want to accumulate. And so in the end, the result of this accumulation is 4 plus 1 plus 1/2, and I'm done, and I can quit out of this thing. And I hope I didn't forget anything. I did forget a little clock signal there, and I'm going to call it done. Hope that helps. See you around.